Greetings everyone, my name is Chimisha Pinto. I'm representing my project team and would like to represent on the project titled AIoT based smart farm security with frequency repellent system. So this is a joint research project between Information Technology Department and Electronics and Communication Engineering Department at College of Science and Technology. So these are the project team for our joint project. So our project is one of a kind in College of Science and Technology, where it involves two departments, IT and EC, to work on single project. So the team consists of 3 EC members and 4 IT members. EC team is led by myself, and we have Srinwanshu and Pemat Hachin in EC. And IT team is led by Udap Parka. We have Wanshu, Sangawanshu and Dipashna Parka. We are led by or guided by our Sir Setan Doji from IT and Madam Pema Zambo from EC. Food security is at the heart of UN's SDGs. So for Bhutan, it directly ties with agriculture, one of the biggest sectors which supports over 55% of the population. However, one of the biggest threats to this sector is due to the human-wildlife conflict. Not only does it affect the crops and livestock, but also puts the life of humans and animals at risk. This statement can be supported by a recent incident where a 33-year-old woman was killed by elephant in Tagana. So there are existing solutions to it, but are not efficient and has many disadvantages. So few of the existing solutions are electric fencing and chain link fencing. So electric fencing had disadvantages such as expensive installation costs, requires constant maintenance, and was hazardous to both animals and humans. Similarly, for chain link fencing, it was very expensive and was difficult to install in large areas. Moreover, the animal repellent system in Paro AMTC was limited to animal habituation, false alarm and manual operation. Not only that, the existing animal intrusion detection system using AIoT, which was developed in 2024 by College of Science and Technology in collaboration with AMTC Paro, had several limitations. Firstly, it lacked the efficient and effective repellent method. Moreover, the AI model was trained on a limited dataset, so therefore it required AI model enhancement. And lastly, the limitations regarding the location. There was inability to locate the intruded animals, which hindered the quick farmer response. To address these issues, we aim to enhance an animal monitoring intrusion with frequency-based repellent system using AI and IoT technologies to ensure crop security from being damaged by animals in Bhutan. So we have 8 objectives. So firstly, we studied the existing animal intrusion detection system and animal repellent system. We have developed AI model using YOLO model, mainly version B10 and B11. We have redesigned and developed the mobile app and web app. We have created a database for data storage and decision-making support. We have designed and developed a frequency-based animal repellent system. We have set up and configured MQTT and database servers. We have studied the feasibility of LoRa communication in the system. And lastly, we have integrated and tested the IoT system and software. So these are the methods we implemented to carry out our project and complete it. Moving on to the architecture solution. So the architecture solution is such that all the IoT components will be placed inside the field, and we'll have our main microcontroller to be used with AI module to detect the specific animals, and via detection there will be a frequency repellent system which gets activated when the AI module detects the animal to deter the animal efficiently. We also have communication system which is included in the IoT system. So when there is no internet connection, the farmer gets notified using call or SMS function to his mobile, and the data or the informations are stored respectively to the database. And moreover, when there is internet connection, the farmer will be notified using the MQTT to the mobile app. And we also have the system admin, where it manages the database and web servers. Move on the frequency repellent system. So this is a simple design which explains the setup of how the frequency repellent system is. So we will be using AC power source to power the microcontrollers and other components. We'll have the main microcontroller which has the AI module, and this will be connected to our secondary microcontroller which is connected by UART. And then after the AI module has been implemented and it detects the animal, by communication with secondary microcontroller, it will trigger or activate the repellent system to deter the animal. So we also have the communication system to provide internet, or we also have LoRa to communicate between two systems. So when it comes to LoRa, if I explain the working, so the working of LoRa can be explained using two systems. So in each system we will have all the functionalities such as the repellent system and the AI system. So if you take an example, if an animal has been detected in system 1, this AI system will detect the animal and it will simultaneously activate the repellent system and the LoRa which is used in both systems. So the LoRa we are using is a transceiver LoRa which can both transmit and receive signals. So when the animal has been detected, with simultaneous activation of repellent system, the LoRa in system 1 will send a message to LoRa in system 2 saying that animal has been detected in system 1, thereby LoRa in system 2 will activate the repellent system in system 2. So vice versa case will happen if animal has been detected in system 2. So we have also designed the casing for our prototype. So the casing design was done in Fusion 360 and we also used software such as CorelDRAW to fabricate the design using the laser cutting machine in tablets, and these are the images for the final product.
Data pre-processing and model training. Data were being collected from various sources and it was cleaned as per the requirement by resizing the image, rotating the image and cleaning the animated and blurry images. AI dataset consisted of 8 classes of animals with 15,000 images in each of the classes, making it up to 1,20,000 images in the new dataset. Now, moving on with the use case diagram of web app. Reads the core functionalities available to the admin in web application. The admin can log in to the system, manage their profile and oversee the total number of intruded animals detected. Additionally, the admin has control over managing farmers' accounts, configuring system components such as sensors or devices and adding new animals to the systems for classification. This diagram highlights the admin's central role in maintaining and operating the entire application. Now moving on with the use case diagram of mobile app. This use case diagram illustrates the key features available to farmers through mobile application. Farmers can log into the app, add new systems or devices for intrusion detection and view or trace animals that have intruded into their fields. Additionally, they can manage their personal profiles and access the help center for support. This diagram emphasizes the mobile app's user-friendly interface that empowers farmers to monitor and respond to animal intrusion directly from their smartphones. Now moving on with the prototype demonstration. This is the prototype demonstration which shows the testing of camera at night with the humans. This prototype demonstration shows the tracking of animals when there is internet connectivity, and once the animal is being detected, it shows the image and the location of the animal. This prototype demonstration shows the detection of animals by calling the user when there is no internet connectivity. This is a live testing done with the frequency repellent system with the dogs. This is also a live testing that was done at night with the dogs with the frequency repellent system. To conclude, YOLO V10 and YOLO V11 enables more efficient and real-time animal classification compared to YOLO V8, achieving higher accuracy with larger datasets and high-resolution images. And also, all these efforts helps to reduce human-wildlife conflict in return. Now, the project showcase. We presented our project on poster presentation on 3rd International Conference of Science, Engineering and Technology, and secured 2nd position in Business Idea Competition on May 9. Then we were also being interviewed by the BBS. Then we participated in the 8th Annual Student Research Meet and secured the 2nd position.